All right, welcome to CSE 116. And before we get too far into it, just a quick informal poll. For how many of you is this your first day having in-person lectures? Just about all of you. That's wild to me. I assume most of you are 3 semesters in and having your first lecture hall experience either right now or earlier today. So welcome to UB, welcome to campus. If you've only interacted with people through a computer screen, you know, welcome. You get the joy of watching us fumble around with classroom technology. Probably in like every class today, you're going to see us fumbling around with how to get inputs and stuff. Mostly because we haven't done that in a year and a half either. So a lot of this is us getting back into it as well. So with that, I'd like to introduce myself. My name is Jesse. I just go by Jesse. We can keep it formal. I like to keep it casual. If you prefer more formality, I'll still respond to like Dr. Hartloff, professor, things like that. If you're comfortable with that, I'm comfortable with just Jesse. Just call me Jesse, and we can keep it at that. We also have several TAs for the course. We have 17 total TAs. A few of them stopped by. They want to stop by the first lecture. I'll give them a few minutes if they want to introduce themselves.
I'm Logan. I'm one of the 3 head TAs for this course. You'll see me sparingly around, but I'm here if you guys have any questions to ask. I'll probably respond to you. I'm John. My name is Marcos. I'll be in some of your labs. And I'm Nicholas.
I didn't even see you there.
6 minutes top.
All right, yeah. I was hoping they'd keep it brief because I got to talk about the course and stuff. You'll see some of the TAs. The TAs will be in your lab sections when you get to lab. Unless you have Logan for lab, hopefully you don't see him too much because you'll see him and talk to him if you're doing poor in the class and we have to have makeup opportunities, which is something we'll talk about. One more logistical note. So I do have to keep the mask on when I teach. I'm getting a face shield. You've probably seen some of your instructors using the shields. I'll do that for audio purposes. But if the audio's bad, I feel like it's ridiculously loud right now. Good? Okay. But if the audio, like if I get into lecture and I start quieting down and slowing down and it's too low, it's muffled from the mask, whatever, just shout out and be like, hey, can't hear you. I think with the face shield, it'll be less muffled and it'll clear things up a bit. But if it's ever an issue, speak up. Let it be known. And this room just got completely renovated. I'm tempted to play with it now, but I won't. But I want to use my dual monitors there for something. I guess we're ready to just talk about the course. All right, so let's go through this thing. At the course website is going to have everything you need for this course or links to the things that you need. The course website is CSE116.com. I've thought about this a while, and I literally cannot make that any simpler. I don't want anybody asking what the course website is all semester. If you ask me, I'm probably just going to make fun of you and not answer your question. Unless somebody adds after, I'll be polite there. But CSE116.com. Everything you need for the course is going to be there. Starting with AutoLab, you should be familiar with this, most of you. This is where we submit programming assignments. So when you have a programming assignment due, that's where you're going to submit, and then it's going to automatically grade your assignment, spit out a whole bunch of feedback. Then you're going to say, what the hell does that mean? And then come to office hours and say, what's going on with my code? AutoLab is the place for that. I'm going to show code examples during lectures. Any code I show during lecture, at least should be, sometimes I slip up a little bit, should be in this repository. There's a lot of code examples here for the entire semester. So if you want to check out the code that I'm showing during lecture, there's all kinds of code examples in here that you'll see during lecture, and you can refer to them there. So if you want to play with those examples, I'm presenting on something, and you say, oh, I wonder what would happen if I change that line. You're highly encouraged to have that code from that repo. Put it in your computer, run it, change it, run it again, see what the difference is, and really get your hands on the examples that I'm showing to get more interaction out of, instead of just watching me play around with the lecture examples. If you want to see all the lectures from the past few semesters, obviously we've been online the last few semesters. All my old lectures are on YouTube. You can go there, check them out. If you want to get ahead of the content in this course, I don't think I changed anything, at least nothing major from last semester. So you can get all the lectures pretty much the same as I'm going to present them this semester, already on YouTube. Just watch last semester's lectures. So any of you want to get ahead, or you didn't like the way I presented it this year, this semester, and you want to see it, how I presented it in an online format, whatever, if that's more what you want, you can check those out. The classroom will record lectures from this semester as well. They'll be uploaded to UB Learns as Panopto videos, and we do, I'm talking to my TA, I think Mike, who handled all my video editing, to see how easy it is or whatever, to get the Panopto videos re-uploaded to YouTube, just so everything's in one nice, convenient place, and you never have to go to UB Learns, at least for this course. I won't use UB Learns for anything else. It'll just be the videos, because that's how the classroom recording works. So if you're looking for any information on UB Learns, it's not there. It's all at cc116.com. Except the videos. If we don't re-upload them to YouTube, that's the one time you would go somewhere else. You go to UB Learns to check the recorded videos. We have a Discord server. If you want to, this is what I wanted to pull up on the other monitor. In the Discord server, there's nothing too official there. Some of the TAs like to hold office hours there, so there might be one little official thing there. But there is a lecture channel, just a channel called Lecture, which I'll be watching during lecture. So let me back up a little bit. So one of the big things that I really liked about teaching online is I would stream on Twitch, and I'd have Twitch chat right there. During my lecture, anybody can type anything, anybody in class can be like, yo, that example didn't make any sense, or you're muted, unmute your mic, things like that, which happen more often than I wanted to admit, how having my mic muted. But that's something I don't want to miss out on. I like having live chat with all of you during lecture. So if you want to ask a question, you don't have to raise your hand, and then I have to shut down lecture, listen to your question, and then answer it. That's, fine, that works, but it can be nerve-wracking, all the eyes turn to you and all that. Just type in the chat, go on the Discord server, type in lecture, I'll watch it right now. This is not discussion about lecture. Right now he's explaining how students can use Discord to ask questions. Rin, one of our fabulous TAs, one of our wonderful TAs, is chatting in there. Priest, who's probably not in this section, not in the room, but that's fine too. So that's there. I see some of you chatting. Hell yeah. Thanks for the dark theme on the site. You can thank Nicholas for that. Nicholas developed that. All right, so that's Discord. I'll be watching that during lectures. I'll give reminders as we go throughout the semester. And if I'm ever not doing that, give me a reminder too. Be like, yo, where's chat? And then I want it on this other monitor here so it's nice and in my face. Today, I'll just use it on my phone. And finally, Twitch. I haven't made any decisions on this yet. Right now, my default is just doing everything in person, except maybe office hours. Once we get the office hours schedule out, I might have Zoom office hours. But by default, I'm doing everything in person. As the semester gets going, as we start feeling out how everything's going to work, and most importantly, as I start pulling you and figuring out what your preferences are, I might start having some lectures on Twitch. Like maybe I'll have Monday lectures streaming, like the past year and a half, like we've been doing. And then like Wednesday and Friday lectures are in person. I don't know. I don't know what it's going to look like. But if I do say, if you ever hear me say something like, okay, next Monday's lecture is going to be on Twitch, I just want to make sure everybody knows what that means. Here's the link to my Twitch channel. That means lecture is going to be there. I'll live stream, if that happens, I'll live stream at lecture time and just present the lecture through Twitch. All right, any questions so far? There are no questions in Discord, no questions live? All right. I guess I didn't really cover anything, so nothing to have questions about. All right, let's get into what 116 is. And I'm used to streaming where what I see, like it shows up the same size for everybody else because you're looking at it on your laptop. So I'm not in practice making sure that what's up here can be seen by everybody, especially in the back row. So if you ever can't see anything, make sure. You'll see me doing this number all the time. It's because that's me going, you're in a lecture hall again. Remember how this works? And I don't remember how this works. I'm getting used to it again. All right, so 116, something I say in 115 a lot. I haven't taught 115 in a while, but one thing I like to say in 115, which I hold to, which I think is true, is after what you learned in 115, you can do anything. You can write a program that does anything you can think of. Now, once you get to a certain point, once you get a fairly complex project and something that's pretty difficult, it might be hard, it might take a long time, it might be difficult for you to write that, but you can. You have all the tools. Once you have data structures, loops, network, do we do network? Yeah, we do networking in 115 still. Networking, I said loops, the 115 stuff. You know what I mean. Once you have those basics, you can write any program. And then a lot of things you might want to pull in a library for, you can do machine learning. You just pull in like Google's TensorFlow, and you can write a machine learning program. You can do some really cool stuff. You can do anything with 115. So what's left in 116 is helping you when you get to that point where your program's getting to be more than a few hundred lines of code, and the code starts to get more difficult to think about and organize. That's what we want to do with 116. What happens when your programs get big? How do we handle that? And to that end, we want to study program execution, which is looking at what exactly is happening, specifically in memory, when you run your program. How is the CPU managing working memory, managing your RAM? How does that work? Object-oriented programming is a way of encapsulating data with functionality. As I'll say in lecture, combining state and behavior, putting them in one thing called an object. I almost said object called an object. And then sharing functionality with other objects in convenient ways. So when you have a set of functions that have very related behavior, we can bundle all those functions together along with the data related to those functions, instead of just writing a bunch of functions and having them all just scattered about the code. Functional programming is similar, kind of an opposite approach of object-oriented programming. It's not bundling those functions, but also focusing on functions with no side effects, where each function is more of a mathematical function. It has, on a certain input, it will have a certain output, which is not always true. Sometimes there are third factors where you can input same input twice and get different outputs, especially with object-oriented programming. Functional programming says no. You have to be more mathematical, more precise, more pure with your functions. And one big reason why we like to do that is because it makes concurrency easier. Whether we like it or not, CPUs have more than one core these days, and apps, huge apps like, think of YouTube, doesn't run on a single machine anymore. Things are distributed. Things are running concurrently. You have multiple things being processed by different processors, by different cores, by different machines, even by different data centers, all to combine and create one experience. And functional programming makes it easier to be able to do that. If your functions are all pure, you can send a function off to another machine, have it spit out the answer, and know that that answer didn't depend on any outside data that it didn't have access to. And more data structures and algorithms. You know a few data structures, you know a few algorithms. We're going to learn more of them. We're going to learn linked lists, trees, and graphs. So there's plenty to learn. Even though I do, because I'll stand by it, even though I haven't said it in 115 in a while, you can do anything with 115, but there's 3.5 more years of education for you, and then in this field, you'll be learning your entire life for decades. You're constantly going to be learning more and more stuff. Even though you can do everything, We're going to teach you how to do it better. And one thing this course will not cover is doing things, writing efficient code. That's what the next 3 years is all about. Getting your code more efficient, understanding more specific problem domains and things like that. All right. This is not an easy course. If you've heard anything about this course, it's probably about how hard it is. This is definitely not an easy course. You've found this out in 115, most likely. Some of you think 115 is easy. That's fine, too. There is a big step up in difficulty from 115 to 116. If you don't believe me, and you don't have to believe me, I mean, a lot of students never believe me no matter what I say on day one anyway, no matter what I say about this section anyway. If you don't believe me, go into the Discord, go into 116 and say, yo guys, is this a hard course? And just see what replies you get. You'll get everyone who took this course will, I'm sure, love to share their opinion. Anyway, this is a hard course. I do expect you to spend 12 hours per week on 116. This is another thing. I think I've heard this in like every single class as a student. I know you've heard it a ton of times. With this class, students that have taken this class will attest that this time we mean it. But you've probably heard that too a billion times. I don't know what the next thing is to say. Like, this time we mean it. It's 12 hours per week. Minimum. A lot of students say they spend more than 12 hours a week. If you ask somebody who's taking the class, they'll say, 12 hours? I was spending like 40. It was a full-time job, just this one course. I don't know how much of that is exaggeration or not, but the point is, this course takes time. If you're here, if you're registered for this course, just know what you're getting into. It is a lot of work. Personally, I think it's super worth it. But it is a lot of work. Don't expect that you're just going to float through this course doing nothing. So 12 hours per week. 3 of that's in this room, 2 of that's in lab. So you're already at 5 hours a week if you just show up to everything. The remaining 7 is going to be on the programming projects, writing code, sitting down at your laptop, swearing at it, banging on your keyboard, things like that, things that you've gone through in 115. If you don't, I hope a lot of you don't have that experience and just write beautiful code that incorporate the lecture topics. But at any rate, 12 hours a week, 7 hours per week. This is an average, so, do your math and stuff. If maybe this week the next few weeks, there's no homework deadline pressuring you, so you don't spend your 7 hours, you got to make up that 14 hours somewhere. So a lot of students just wait till the day before the deadline, or the day before the checkpoint, and just put in 40 hours right there because they didn't do anything the previous 3 or 4 weeks. So that averages out. So I don't want to hear any complaining, you're working so hard at the homework deadline. I like to just do the math. I'll say, well, how much have you done the previous several weeks? The numbers add up to 7 hours per week outside of class. That's how much you just spent on homework. You just did it all in 2 days. And if that's how you work, go for it. I'm not going to tell you not to do that. Just don't complain to me if you didn't get it in. So those are my expectations, and I design the homeworks around that. What I believe takes, I see that as time that I have to allot. I got 7 hours per week of your time. That's what I'm designing homeworks for. If, like in the past, students complain too much, and I feel like it's going over that, I tone it back. If the homework's a little too easy, I'll tone it up. Like, I've tuned this class to that pretty well, I think, by this point. This 12 hours per week assumes that you know all of the CSE 115 material. I think this is one of the biggest dangers of a course like this, and really the whole field, all of computer science, is you're learning like a whole new field. Each one of these courses builds on the next one. So if you got through CSE 115 with like a C, you just barely squeaked by. After the final exam, you forgot everything you knew. You spent the whole summer doing anything besides writing code or thinking about code, which, by the way, that's fine. You can do that. But just know that you got a lot of catching up to do. This 12 hours per week assumes that you know all of the 115 material. If you don't know all the 115 material, you already have some catching up to do. You already got to do some work to get that information out there. And the same is true after this course. You go into 220, 250. You're expected to know all the 115, 116 material. So it really is like learning a brand new field. I like to compare it to learning mathematics. You learned how to add and subtract in 115. Now I want to teach you how to multiply and divide. But if you don't understand addition and subtraction yet, you can't teach somebody how to multiply and divide if they don't understand, okay, multiplication, it's like adding a bunch of times. And somebody goes, what's addition? It just doesn't work, And not to go down this road too far, but unfortunately, from my position, obviously I'm biased, but you get 13 years to learn mathematics and they slowly build you up. We're building you up in 2 semesters here, teaching you like all the fundamentals. It's a fast pace. It's a lot to go through in 2 semesters. I recognize that, but because we have nothing to build on, we start you at 115. Oops. There's not lab week 1. I did not update that. I apologize for that if anybody showed up to lab. Nobody has Monday lab, so nobody showed up yet. But there's no lab week 1. I should update that. Actually, Nicholas, can you update that? Just remove this, yes, there's lab week 1. And this is just me doing my math. I don't want to drone on this too much, mostly because the people who really need to hear it don't listen anyway. If you want to review 115, I have some resources here. If you, the UB Infinite app that we use in 115, I have a version of that with all the same questions, but all of the prereqs are removed, so you can just go and study just the things that you want to study. Old lectures, old course website, so you can get all that information. And I guess I haven't mentioned this yet, but this course is going to be in Scala. So we are learning a new language as well. So when I say know the 115 material, I don't mean memorizing Python and JavaScript syntax. I mean understanding the concepts that you learn. What's the idea of looping over a data structure? I need you to know that kind of stuff, the conceptual knowledge. Okay. And pretty much the entire rest of the time, I gotta talk about our grading scheme. The grade thing's a bit different in this course, and we'll talk about all that. Yeah.
CSE classes after this, are you using Scala too?
It depends on the class. Some of them, like 250, will use Scala. 220 is going to be in C, and then 300 and 400 level classes, it's depending on the instructor. So the idea is by the end of your 3rd semester, you'll know 4 languages, and by the time you learn 4 languages, you're going to understand the concepts, and learning your 5th language should be a lot easier. That's the idea. That's the educational reasoning behind that.
I didn't take the 115 course, scripted.
Mm-hmm.
What did you guys learn Python?
It was Python and JavaScript in 115. But as long as you know the concept, that's kind of the benefit. If you're a transfer student or you didn't take 115 here, but you must have programming experience though if you got 115 with. Yeah. So as long as you know the concepts, I assume nobody here knows Scala. So I'm going to start the language from scratch. But I do expect you to understand the concepts of loops, control flow, data structures, lists, if statements, if, else. As long as you know those concepts, you'll be good. All right, the grading structure. Grading's a bit different. There's no concept of points in this class. There's a very loose definition of a deadline. A lot of things are pretty strange, so let's go over that. That's what I want to spend most of today doing. Hopefully I didn't ramble too long about the other stuff and we got time. So the course is divided into 4 learning objectives, which are outlined right here in the syllabus. I'd say this is the most important section of the syllabus that I'll refer back to most often throughout the course. These 4 learning objectives are broken into 3 separate pieces: a read, explain, and write portion. Your task for this course is to learn all of the learning objectives. You complete all of the learning objectives, learn all the things you need to learn, then you're going to pass the class. If you miss any of those, if any one of these is not complete, out of the 12 total portions, I've been calling portions of learning objectives, then you fail the class. So this is what I need you to do, is complete these learning objectives. And if you do, everybody's happy. If you don't, it's not the best. So read, explain, and write. Read. This is going to be in your lab quizzes. You're going to be given some code. For each learning objective, you'll be given some code. You have to read that code and explain what it does. We call those lab quizzes. You have to show me that you can read code pertaining to that learning objective. Explain, and then for each learning objective, I have very specific what I expect from you. Explain. This is going to be through interviews, again, in your lab with your lab TAs. While you're taking the quiz, a TA is going to approach you at some point and say, it's time for our interview, let's do this thing. And they're going to ask you questions about the concepts of that learning objective. That's explain. And then write is what you spend probably most of your time doing, the most time doing, is writing your program, completing your program assignments, submitting to AutoLab, and having AutoLab tell you how you did or not with the auto-graded assignments. So 3 portions to each learning objective, 4 learning objectives, 12 total things you need to do to pass the class. And once you do, you pass. And I got this nice little chart to make sure that's clear. 0 through 3, failure. Once you do pass, I have something called application objectives. There are 2 of these on each homework, and then the final exam I'll have another 2. That's a total of, there's 1 homework per learning objective, I didn't mention it. So that's a total of 10 application objectives you can complete. And then your grade is determined by how many of those you complete. If you complete all the learning objectives, you're passing the class for sure, even if you don't touch the application objectives. And if you get at least 6 out of those 10, you're going to get an A. The reason I have things set up like this is I need you to know certain things when you leave this class. When you go on to 220, 250, those are the learning objectives. I'm clearly stating them and saying I need you to be able to do these things. And if you can, I got no qualms with you. Knock out some application objectives and get your A. If you don't, I just need you to know those things. If you skip one of those things, if you don't complete one of those learning objectives, you're not adequately prepared for the next semester of computer science. So right now, that probably sounds pretty scary. So let me talk about how to complete each one of these. And the most important thing to me, since I do have this, what I call 4 or fail, I do have this pretty seemingly strict, at least, criteria. I want to make sure I give you lots of opportunities to complete those 12 portions, those 4 learning objectives. So I'm giving you as many opportunities as you can. I don't want anybody failing the course who does understand the material. If you absolutely know that you've completed all 12 of these, if you actually do, in your head, you have all this knowledge, you have all this understanding, you have completed them, it's my job to find that out, figure out that you've completed them, and pass you in this course. That's my job. I have to assess you. I have to figure that out. Your job is to focus on the learning and make sure that you can complete all those things, that you do understand the concepts, that you watch the lecture and you can explain to somebody what concurrency is, for example. You should be able to do that by the end of this class. If you focus on the education and you focus on that learning, I'll find out and I'll be able to give you an A, or at least a passing grade, depending on your application objectives. So how I'm going to find that out, and obviously there's too many of you for me to do that personally, how I'm going to figure that out is through an army of TAs in lab. With the quiz and interview, there are on the schedule verification labs for each learning objective. And during that lab, you're going to have your hour and 50-minute lab time to complete the quiz, where you have code samples and you explain them. And during that, the TA is going to interrupt you and say, hey, we got to do our interview. And those are going to be pass-fail. You'll find out whether you either completed the learning objective or you didn't. There's no grades. It's just, did you complete this thing? That will be reviewed by an actual human being. We're not going to automate any of that. A human being with a human brain is going to look at for example, your answers for the quiz and for the interview. By the way, your interview TA is going to report a summary of how the interview went. And then another human being is going to look that over and determine if you understand what you're talking about or not. Were you able to explain this or not? If you didn't, there's a second lab on the schedule for each learning objective, the second chance lab. You didn't pass either the lab, the interview, or the quiz, you go to the second chance lab, you try again. You don't pass that one, well, you just fail the class? No, you don't just fail the class. I want to give you opportunities. If you don't pass that one, you're going to be contacted by another TA, probably not one of your lab TAs, depending on just what lab you're enrolled in, I guess. And they're going to give you a third opportunity. For that one, the quiz is going to be an interview. They'll show you a piece of code, and then if you adequately explain that code during the interview, then you pass. If you don't get that third opportunity, then things get a little more ambiguous. I left myself some wiggle room in the TA, some wiggle room in what to do here. You may or may not get some other opportunity in here, but at worst case, your fourth opportunity, we're up to 4 already. I want to give you lots of opportunities. If you actually know your stuff, you better not, there's no way you can fail all 4 of these opportunities. Your fourth opportunity will be with me. Nobody fails the class without seeing me. You're not going to get screwed because the TA was in a bad mood or something. You only get screwed if I'm in a bad mood when you interview with me, I guess. It might not have been the best way to say that one. But your last opportunity is always going to be with me. You're going to have a chance to come up against the final boss, and if the final boss kills you, well, that's an F in the course. But at least 4 opportunities. And there are legitimate reasons why you might get to the fourth. Maybe you were sick for 1 or 2 of the labs. By the way, if you're sick, especially since it's a pandemic, if you're sick, don't show up. Stay home. The whole course is built so you can miss labs, you can miss lectures, and get caught up. If you miss the verification lab, just go to the second chance lab. Don't come in sick. Please, please, please. Don't come in sick. But maybe you're sick. Maybe the next time, I was sick, I'm still catching up. You don't get the second chance lab, contacted by a TA, and you knock it out the third chance because you knew your stuff, you're just feeling under the weather before. Something I don't like in any class is I don't want one bad day on your end to cause you to fail the course or even get a bad grade. I'd never like that as a student. I'm not going to do it as a professor. Okay, and so that's lab and quiz. For the coding, there are checkpoints in the schedule. For example, Learning Objective 1 checkpoint, Friday, October 1st. That's going to be when we check your completion of Learning Objective 1, which the big thing we have to look at is the right portion. It's pretty easy. We just look at the AutoLab feedback. If AutoLab says you completed it, then you completed it. If AutoLab says you didn't complete it, then we have a decision to make. Do you just fail right there, or do we give you an opportunity to make that? Of course, I'm going to give you an opportunity. This is all about opportunities. So if you don't complete it by that checkpoint, and you've shown that you were working on it, that you have, ideally you've had submissions throughout the entire time the assignment was out, you've been working on it, you made progress, AutoLab says you're kind of good, but you just didn't quite get there. In that case, you're going to get an extension, you're going to get a 1-week extension, and then after that week, then I have tough decisions to make. I got to decide what happens after that. But you're at least getting that 1-week extension. You can pretty much guarantee that one as long as you've been working on it. If you haven't made any submissions before the checkpoint, I'm liable to just say, no, you haven't even tried. Sorry, you didn't complete that. That's where your right ends. But if you've been trying, if you've been showing effort, and the ruler we're going to use to measure that is, do we see 12 hours per week of effort from this student? If yes, 1-week extension. So if you've been working on the assignment in earnest, you can just keep working through the checkpoint. I have a lot of students last semester who at the checkpoint would stop working and then email me and say, am I getting an extension? If you've been trying at all, you're getting an extension. You'll get let me word it this way: if you don't get the extension, you failed anyway. Like, at least try. At least try. And I've even made decisions where I would have failed the student, but I saw that they worked past the deadline and just kept working on it, and ended up giving an extension based on that. So keep working. Don't stop at the checkpoint. If at the checkpoint you're not complete, you need an extension, you need a second chance, or a third chance. We're going to put you on what I call a recovery plan. You'll get an email with the details confirming if you've got an extension, if you have another chance to do the quiz, if you have another chance to do the interview, the details, the scheduling details of those interviews, because those ones will be outside the lab if you need a third chance. You'll get a recovery plan with those details. And I'll repeat it again. If it's clear you've been putting in your time, these recovery plans can be more generous. I'll work with somebody who's just, if you're working your ass off and it's taking you a little bit longer than you expected to get the material, whatever, I'll work with you. To an extent, of course. Obviously, the one unfortunate thing is we do have the ultimate deadline of the end of the semester. We can't do anything about that. Like, at some point, I have to put grades in the book, and if you're not done by then, there's not much I can do there. I think that's the final exam will have an opportunity to get 2 application objectives. There are 8 application objectives available on the homework assignments. You need 6 to get an A. You can do the math here. If you have 6 or more before the final exam, I shouldn't see it at the final exam. You can, go home early if you don't have any other exams, or use that time to study, whatever. Final exam you don't have to show up to, which goes with I don't want one bad day to ruin your semester. Final exams is like the ultimate of that. You need the final exam to pass in some classes. Man, that's rough. What if you're not feeling well that day? So the final exam, just show me throughout the whole semester that you know your stuff, and I don't need to see you on the final exam. You already proved what you need to prove to me. No textbook. Don't cheat. I like the upper level courses because I don't have to dwell on this because everybody's heard me and other professors say it so many times. Y'all might have only heard it like 4 or 5 times, at least from CSE professors. So I'll say it again. Don't cheat. That's all I got. No, I got more on this. So all violations will be an F in the course. I don't care if, so let me define cheating in this course. If you've seen somebody else's code or somebody else can see your code, you're walking a very fine line. Technically, you've already committed academic integrity at that point, but I can't tell at that point. But if I have 2 submissions that look sufficiently similar or suspiciously similar that I believe that the only way that could have happened is that if those 2 students had some form of code sharing among them, then both students are going to get an F. Whether you're the one who cheated or you're the one who gave another student your code, I don't care. Personally, I think if you're giving somebody your code, I think you're the worst. Not the worst. That came out wrong. I think you're the worst of the 2 individuals involved. It's like if there's illicit drugs, we'll say, happening. Who's more in the wrong, the user or the dealer? I think it's the dealer. I don't like the people who deal solutions. So I think that's even worse. It doesn't matter because you're both getting an Fs anyway. But if you're giving other people your solutions, like, you're the core of the problem. Cheaters can't cheat if they don't have someone to cheat off of. So I will definitely go after people giving their solutions away. Yeah.
So what if, for example, you cite code, let's say you wanted to write like a hash table and you borrow a hash algorithm from someone who cited, is that okay?
So if it's a large amount of code that you're taking, so the question is, if you use code and then cite it, is that fine? If it's a large amount of code to the point where I can't assess the learning objective, then that's not okay. But if it's like 1 line of code, yeah, cite your source. I'll be fine with that. If it's a small, a line or 2. Once you're pasting a 10-line algorithm from Stack Overflow in your code, well, now we got problems. And some of those are easy to detect once, so we have software, obviously you probably heard this, you're probably aware of this, but we have software that checks all your submissions. I'm not going to manually look at all your submissions, I just dump it into the software and it spits out answers. So once 2 people copy the same Stack Overflow question, that's when you're going to get flagged, and that's when it'd be bad. But if one of you has a cited source that actually has that code and one of you doesn't, it's always better to cite. The most common form of academic integrity is right here. I've had far too many meetings like this where, I believe the students, I believe that they didn't do anything wrong, but unfortunately I got to give them Fs. And they're really, I don't know, I hate having the academic integrity meetings. I have to stare a student in the face and say, you failed this course. And sometimes they break down crying and stuff like that. It sucks. I hate those meetings. I probably don't hate them as much as the student, but I still hate them. And this is the most common meeting and one of the toughest ones to have too, because I still have to give you an F if you do this. But when you're working with your friend, you're sitting side by side and you can see each other's code and you often look at each other's screens and basically work on the assignment together. A lot of times students don't know that they're crossing the line when they do this, but guess what happens when they make their submissions? It pops up on my radar and I'm looking at 2 submissions that look almost identical, like line for line, because you're just, what did you write? Oh, you used a loop, you looped over that data structure and then you type it. You end up getting 2 assignments that look almost identical, and then they're always like, well, we didn't cheat, we didn't share code. Well, yeah, but you did the assignment together. I can't be confident that both of those students could do that assignment independently. I can't confidently say that both of those students completed the right portion of that learning objective because they had to work together. They had to work together to do that. Don't cross this line. If you can see your friend's code or your friend can see your code while you're working, you're walking a very fine line there, and you don't want to have that meeting with me where I have to say, sorry, you got to retake this course. You're getting an F. You don't want to do that. Don't do that. Now, what you can do is talk about conceptual information about the assignment. You can talk about your approach about an assignment. Okay, we have to make this genetic algorithm, so I'm going to make a cost function. That cost function is going to assess, it's going to tell me how far the points are away from this line. That's fine. That's all on the table. I want you to work together. I want study groups and stuff, especially a course like this, it can help to be going through it with somebody. Just when it comes time to write the actual code, you have to do that independently. You have to write the code on your own. Even if you're sharing the high-level ideas, if you have the same exact approach to a problem and you both write the code separately, you'll be surprised how different the code comes out. You'll both have, it's like writing. Everybody has their own style. Programming is the same way. You all have your own style of writing code, and those styles are going to show, and then you're never going to show up on my radar because those things will be very, very different. But if you can see each other's code, your styles end up looking very similar. The order in which you initialize variables is usually a silly thing because, statistically speaking, if you got 5 variables, you're not both going to initialize them in the same order, things like that. But if you work together, you're going to, or if you straight up cheat and steal somebody's code, you're going to have them initialized in the same order. And of course, I don't want you fighting over false positives. I'm very serious about no false positives when it comes to AI. You have to actually be cheating to show up on my radar. If you're writing your code separately, I've had students where they write their code separately, and after they both submit, they look at each other's code, and they're like, oh my goodness, they're like the same exact thing. No, they're not. To show up on my radar, there's, the same style. There are a lot of differences that if you wrote them differently, maybe you don't see them, but they're very obvious on my end. If you didn't actually cheat, those differences are going to save you. All right, that's enough AI stuff. And I think that's all I really want to talk about. If you want to get started for next lecture, we're going to use IntelliJ to write Scala. if you want to go through the tutorials and get IntelliJ running, that's where I would start. If not, question? No lab. Okay, no lab this week. Lab next week, though. And with that, I'll see everyone Wednesday.